very few chemists who haven't done that. Because most of us don't do it in one step. We take the ester, we deprotect it, we activate it, typically as an acid chloride or something like that, and then we add the amine. Not a very effective procedure, really. We know that biocatalysis has been shown to do this in one step. But again, it's been done occasionally here and there. It's not a general tool. Redox reactions, so trying to move away from some of the more complex systems which take advantage of osmium, chromium, precious metals. This is clearly of importance. Very high on our agenda would be fluorination. It depends where you read, but a current estimate of NCEs coming to the market today, about 40% of those will actually contain a fluorine molecule. Big numbers. And anyone who's looked at fluorine chemistry will know that this could never be considered a green process. Fluorination is just atrocious. We do it because that's what we need to do. But there is some basic work being done on fluorinases. This is an area where we could have a big impact. Remote hydroxylation, we see this all the time. And obviously this is something of great interest to anybody who's making any kind of API. You can see where it had two big impacts. From a fragment-based approach, you can see the introduction of hydroxyl groups in a chiral sense onto small fragments will be tremendously useful for people building up libraries. On a more traditional sense, perhaps, you can actually see this and think about this in terms of metabolites, first-pass metabolites. So again, something very important and somewhere where we'd actually like to see progress. Synthetic biology. This is clearly an emerging science, tremendously important to the pharma industry. The idea is really to look at the chemistry we do today, and although this is some years away, the aspiration would be to do all our chemistry today in a cell. We're miles away from that. But there are some great examples in the literature of where multiple stages have been done in simple fermentations. And I think everybody who's in the field will have heard of the artemisinin example. So this is something we're particularly keen on. To actually achieve this, there are certain things we need to do, fundamentals, rather than looking at individual projects. There are certain background steps which need to be put in place. So we need genetically stable recombinant systems. When we think about this, we really want to go from small scale all the way up to manufacturing, ideally using the same organisms. Those organisms need to be non-pathogenic. We need to actually understand those and be able to predict the kind of chemistry we can actually do within those organisms. Clearly, they've got to be suitable for scale-up. And of course, we want something which is going to be sufficiently robust that it can actually withstand downstream processing. Clearly, as a consequence of having this, we're going to want demonstration of this technology. So we're going to want to see examples of multiple steps to create API-like molecules. And of course, what all of this will actually lead to is a greater understanding of some of the limiting factors associated with this science. The fifth work package, again, is something that's fairly fundamental to us. This is all about education. I think very few universities, even today, actively push a green chemistry agenda. This is something that will need to change. So we're actually seeking to demonstrate earlier adoption of green chemistry methodologies. This needs to happen right at day one. When a chemist is actually thinking about the best way of approaching a transformation, they should be thinking, green approaches first. We need sustainable routes to be taught. And we actually need widespread development of sustainability metric tools which are actually suitable for use in early development, and I stress that, early development, by academia and industry. As you go into the pharma industry and you look towards later stage projects, a huge amount of metrics and work are done for those, each company probably doing it slightly differently, but we think about that a lot. So we want a simple tool which can actually be picked up and used by you know, someone looking at a particular route for the very first time. Industry can provide materials and synthesis, but we really need the consortium to deliver the greener synthesis and evolve this broader educational approach. So those are our 5 work packages.